In this video, we're going to talk about two concepts. And the first one is going to be what we call the DeMorgan laws for quantifiers. Morgan laws. So we've seen DeMorgan laws before when we talked about the connectives of the negation and conjunction and disjunction. And then the other concept that I'll leave to the end of this video is the relationship between the universal quantifier and the conjunction and the existential quantifier and disjunction. Okay, so let's start with the DeMorgan laws for quantifiers. The idea here is the relationship between the universal quantifier, the existential quantifier, and negation. So let me start with the negation, say, of a universally quantified sentence. So let's let S just be some type of predicate. We can read it as small if we like. So we have the negation of a universally quantified sentence. So the universally quantified sentence, we look just inside here, right, is saying that every object in the domain satisfies some condition, in this case being an S. And then the negation out front here flips the truth value of that, right? Or strictly speaking, right, when we think about this in terms of quantifiers, we're saying it's not the case that everything in the domain satisfies this particular condition. So if we think about it that way, right, that it's not the case that everything satisfies some condition S, we can read that then as being equivalent to, so notice that I'm here using this double arrow, biconditional arrow, but it's not the biconditional, right? Because this is something in our meta language. We're saying that there's two sentences in the object language that are equivalent. So the negation of the universally quantified sentence is equivalent to the existential claim that negates what was going on the inside of the previous sentence. So to say that not everything satisfies some condition is to say there is something that fails to satisfy that condition. Right? So if we say, for example, it's not the case that everything is small, is equivalent to saying there is at least one object such that it is not small. Right? So if we say everything, it's not the case that everything is small, that means there's at least one thing that is not small. So that's the first equivalent. The negation of a universally quantified sentence is equivalent to the existential statement that negates the satisfaction condition on the inside. Notice that this is not just a left to right direction, but also a right to left. So if you start with an existentially quantified sentence, you can then convert that into the negation of, oh, that was a terrible arrow. You can convert that into the negation of a universally quantified sentence. Sometimes you might find this really, really helpful. So in cases like with the DeMorgan's laws, we often talked about how thinking about the negation of a conjunction can maybe be a little bit more difficult. And it's sometimes easier to think about the disjunction of two negations. Or same thing with like the negation of a disjunction is sometimes easier to think about in terms of a conjunction of two negations. So these equivalences are also going to be helpful for similar reasons. Sometimes it's easier to think of an existential quantifier, and sometimes it's easier to think about things in terms of a universal quantifier. Okay, so let me give you the other DeMorgan law for quantifiers. You might have guessed that it's going to be really similar, except we're going to swap out the existential and universal quantifiers. So in this case, we have, instead of the negation of a universal quantifier, we have the negation of an existential quantified sentence. So it's not the case that there exists an X such that S of X. That's going to be equivalent to the universally quantified sentence that has the negation pushed in. Looks like this. Right? So this is saying it's not the case, so this left one, right? It's saying it's not the case that there's at least one x that is small. That means everything in the domain fails to satisfy the condition of being small. And the right to left works as well. If everything is not small, then what that's saying is that it's not the case that there is at least one thing that is small. So those are equivalent ways of saying the same thing. So in addition to paying attention to quantifiers and the way in which they provide information about what's being stated in the sentence, we also have to be really careful about the position of the negations. But one of the sort of neat things that we can do is recognize these types of equivalences, right? So that the negation in front of a quantified sentence is going to be equivalent to pushing the negation in, like we've done here from the left to right direction, and then swapping out the quantifiers, right? So you replace the existential for the universal, or you replace the universal for the existential, in a really similar way as we did with the DeMorgan laws for the connectives, right, for conjunction and disjunction. Okay, so related to quantifiers and these DeMorgan laws is the relationship between the quantifiers and conjunction and the universally quantified sentence and conjunction, like the existential quantifier and disjunction. So let me clear this up. So in one of the exercises that you're going to do for this problem set is explore the relationship between the universal quantifier, right? And then there's some connection that it has with conjunction. And there's some relationship that the existential quantifier has with disjunction. And here's what we have in mind, right? So if I have a statement that says for all x, s, x, if I have a domain of objects and I give them all like temporary labels, so this had to do with the concept of satisfaction that we used. So let's say I've got 3 objects in my domain, right? So I've got my domain. Oh, sorry. This drawing did not work as I thought. So I have my domain, and let's say I've got 3 objects, right? I've got the thing, the same with n1, and I've got n2, and I've got n3. Those are the objects in my domain. And I'm using n sub 1, n sub 2, n sub 3 to just indicate, right, that these are just temporary labels that I'm giving to each of those objects, just so that I have something that I can use to denote them with. So the universally quantified sentence is in this particular domain going to be equivalent to the sentence that says n1 satisfies s and n2 satisfies s and n3 satisfies s. So this universally quantified sentence is in this particular domain going to be equivalent to a conjunction where we've replaced the variable x with all the objects that we could name, right? So we've given them sort of pretend names to be able to pick out all those objects. If we had a 4th object, say n4, then we would also have to include s n4. So one way to think about a universally quantified sentence is like giving a fake name to every object in the domain. And then what you do is you take this condition and you build a huge conjunction where in each conjunct has the argument spot where X was filled in with that name. The existential quantifier is going to be really similar, but instead of a conjunction, it'll be a big disjunction. So this will be SN1 or, or SN2, and then in this particular domain, it'll have up through SN4. So again, this existentially quantified sentence is going to be equivalent to, in this particular domain, a disjunction. Why? Well, if we think about the meanings of these quantifiers, right, the universal quantifier is saying that every object in the domain satisfies that. So that means that N1 has to be an S, and N2 has to be an S, and N3 has to be an S, and so forth, until you've gone through the entirety of the domain. The existential quantifier, right, an existentially quantified sentence, is going to be roughly equivalent to the disjunction, because you just need at least one object in the domain to satisfy that condition. So either N1 is an S, or N2 is an S, or go through the whole domain, N4 is an S. So that's a sort of a way that you can think about the relationship between the universal quantified sentence and conjunction, and the existential quantifier and disjunction. A big caveat, however, I don't want to say that they are in fact equivalent to core. That's to say that they're always equivalent. And the exercise that you're going to do for this problem set is to realize why they're not. And part of the answer has to do with the fact that the conjunction always has to have some domain in mind in particular, because this conjunction can't necessarily be infinitely long, right? Conjunctions typically are finite and they apply to a particular type of or particular domain. The universally quantified sentence is going to be more general than the conjunction. So it's okay to think about this sort of roughly to help build the intuition, but it's really important to recognize that strictly speaking, a universally quantified sentence is not equivalent to a corresponding conjunction, even if in a particular domain they would end up giving the same answer. And the same lesson holds for the existential quantifier. Okay, so that covers the DeMorgan laws for quantifiers and the relationship between the two quantifiers and conjunction and disjunction.